Hello guys, today we're going to be talking about Cartesian product and relationships in DMS. So Cartesian product, if I were to define it, when we have two sets A and B, Cartesian product of A and B is written as A into B, so that x is used as a operation symbol between A and B set. So if if A and B are in a Cartesian product, they are said to be in an ordered pair as well. That means a set A and B contains A as a subset and B as a subset for B. Let's say, for example, set A as 1, 2 and B as x and y. Then A into B is nothing but 1x into 1y, 2x and 2y. That means unless A is equal to B, the full context allows it to be symmetrical in shape of the set. So relations is nothing but a relation from set to A to B is a subset of Cartesian product that A into B. Cartesian product is nothing but A into B. So R is a relation. R must be a subset and equal to A into B, the product of the two sets. That means if A and B same as R is present in both, which is 1x and 2y. That's what it means. So there are multiple relations in on set A we can do, which is reflexive, symmetric and antisymmetric and transitive. Reflexive is nothing but when a set has two distinctly same elements, that's called reflexive. Symmetric is nothing but when it has two different elements, but also there's another possibility and another ordering of element is done in symmetric. For example, in reflexive, A comma A is present in reflexive, whereas symmetric, A comma B and B comma A is present in the set A. Antisymmetric is just the opposite of as similar as to the symmetric. A comma B belongs to relation R, whereas B comma A belongs to relation R. That means A is equal to B. That's antisymmetric. Transitive is nothing but if A belongs to R and BC belongs to R, A comma C belongs to R. So all of the three possibility are is belonging to relation R. That's what is meaning of transitive. Okay. That's all for relation and Cartesian products. Thank you guys.
Understanding the foundation. What are Cartesian products? Cartesian products combine different sets. We take elements from two sets and form ordered pairs. The order of these elements matters greatly. This product creates an entirely new set, named after René Descartes, who used coordinates in geometry. Imagine set A has m items and set B has n items. The Cartesian product AXB will have m times n items. This multiplication gives the total number of pairs. An ordered pair is typically written as AB. A comes from the first set and B from the second. The pair AB is different from BA, unless A equals B. This specific order is crucial. Cartesian products are foundational in mathematics. They help define concepts like functions and relations. Understanding them is key for advanced mathematical topics. They provide a systematic way to list all possible pairings. Cartesian products serve as essential building blocks. They help us clearly define other concepts. Cartesian products in action. Simple examples. Suppose set A contains 1, 2 and set B contains x, y. The product AXB includes pairs 1x, 1y, 2x, and 2y. There are 4 pairs in total. Each pair combines one number from set A and one letter from set B. Now consider the product BXA. The pairs in BXA are x1, x2, y1, and y2. Notice 1x is not the same as x1. AXB is generally not equal to BXA. We can also multiply a set by itself. Let set SB heads tails for a coin. SXS shows 2 flips, heads heads, heads tails, tails heads, and tails tails. This is useful in probability to list all possible sequences. We can use more than 2 sets. Consider 3 sets, A, B, and C. The product AX, BX, C forms ordered triples like ABC. A is from set A, B from set B, and C from set C. This concept extends to n different sets, creating n tuples. Cartesian products help handle complex data. They provide a clear way to list all possible combinations. This is essential for understanding more advanced topics. The reach of Cartesian products. Applications in math and life. Cartesian products are vital in geometry. The Cartesian coordinate system uses them. Any point, x, y, on a plane is an element of Rx,R. Three-dimensional space uses Rx, Rx,R for x, y, z, triples. This system describes geometric space precisely. In computer science, databases rely on these products. Each row in a table is like a tuple from a product of column values. For instance, a row could be student ID, name, course. SQL database joins can involve Cartesian products. Consider a restaurant menu: mains equal sign, burger, pizza, drinks equal sign, soda, water. All possible meal combinations are in mains X drinks. These are burger soda, burger water, pizza soda, and pizza water. Businesses can list all their offerings systematically. When buying a car, you choose a model, color, and engine type. Each choice comes from a specific set of options. Your final car configuration is an item from a large Cartesian product. This principle applies to many customizable products. Cartesian products help in planning and inventory. They provide a systematic way to list all possible combinations. This is essential for understanding more advanced topics. Section 4. Building bridges. Introducing relations in mathematics. A relation links elements from one set to another or within the same set. Formally, a relation is a subset of a Cartesian product like AXB. If AB is in relation R, A is related to B by R. Cartesian products list all possible pairs. A relation selects specific pairs that satisfy a condition. For example, let A equal sign 1, 2 and B equal sign 1, 2, 3. AXB includes 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, and 2, 3. A relation less than from A to B includes 1, 2, 1, 3, and 2, 3. Another relation is equal to includes 1, 1, and 2, 2. Relations can also be defined on a single set. For example, the set of integers z with the divides relation. The pair 2, 4 is in R because 2 divides 4. Relations model various connections and structures. They are used in social networks, project tasks, and data structuring. Relations formalize abstract relationships, making them analyzable. Section 5. Classifying connections. Key types of relations and their importance. A relation R on a set A is reflexive if every element relates to itself. For example, the is equal to relation. A relation R is symmetric if A, B, and R implies B, A is also an R. For example, the is a cousin of relation. A relation R is transitive if A, B in R and B, C in R imply A, C is in R. For example, the is less than relation. An equivalence relation is reflexive, symmetric, and transitive. It groups similar items into equivalence classes. For example, the has the same color as relation. Understanding Cartesian products and relations is vital. They are key tools in logic, database theory, and graph theory. They help define order and equivalence. These concepts are essential in discrete mathematics. They provide a systematic way to analyze relationships.